For centuries, education has relied on a reliable physical assumption. We stored knowledge in static volumes, and students came to access it. But that architecture is evaporating into a continuous, dynamic network of instantaneous information. We built our teaching models around a linear pipeline. The instructor sits at the beginning as the sole knowledge authority, passing information through a static delivery method directly to the student, who produces an output. Generative AI breaks that pipeline. A student uses an AI system to instantly generate the output, bypassing delivery entirely. To understand this shift, we must look at how these systems operate. They synthesize new, customized responses in real time, functioning as dynamic, adaptive learning networks rather than static indexers. The mandate of the educator used to be content delivery. You spent your time packaging facts and explanations. Today, the system generates that packaging on demand. Because AI commoditizes basic content generation, the traditional model of the educator acting as the sole bottleneck of knowledge is obsolete. We need a new model. To adapt, we rebuild that broken pipeline into a networked architecture. The instructor moves to the center of the system, evolving into a learning experience architect. Your role is now to manage the flow of interaction between the student, the subject matter, and the AI. There is a strict difference between typing a question into a text box and actively directing a complex pedagogical system. One is using a tool, the other is orchestration. The specific capability required to manage this new architecture is called AI Fluency. True AI Fluency requires zero coding skills. It is a high-level operational strategy for human-machine collaboration. It is knowing exactly how to command the system to build the learning experience you want. We operationalize this strategy through the 4D AI Fluency framework. This is your execution protocol. It acts as a repeatable operating system. Whether you are using ChatGPT, Claude, or a specialized educational tool, the logic of how you interact with the machine remains exactly the same. Phase 1 is Decompose. You should almost never ask an AI to execute a macro-level task like design a course. The system lacks the localized context to build something that large from scratch effectively. Instead, you must break that macro task down into distinct, isolated instructional components. You isolate the Bloom's taxonomy objectives. Then you separate out the scaffolding strategies, and finally, the assessment outlines. An AI system cannot function effectively without this human-led task segmentation. Strategic isolation is what prevents generic outputs. Once decomposed, we move to phase 2, Delegate. Here, you match specific pedagogical tasks to the capabilities of the system. Generating a draft rubric or outlining a lecture sequence are structural tasks. Delegate those. But high-level student engagement strategies, empathy, and real-time mentorship, those must remain entirely human. Phase 3 is Describe. This is the execution of sharp, precise prompting. A successful prompt requires rigid instructions. You need to provide the environmental context of your classroom, strict structural constraints, and the exact cognitive goals you want the students to achieve. Directing the AI to target a specific tier of Bloom's taxonomy, such as evaluation rather than recall, changes the structural logic of the materials it generates. The quality of the AI-generated educational materials is strictly bounded by the precision of your description. Vague inputs yield useless outputs. The final phase is Discern. The moment the AI produces text, your role undergoes an immediate shift from creator to auditor. You critically evaluate the output, ensuring the material makes logical sense and perfectly fits your curriculum. This is where you filter out bias and hallucinations, instances where AI generates plausible but false information. Academic rigor demands human verification. You run a strict decision matrix. You identify what is ready to use, what needs to be fed back into the prompt for refinement, and what needs to be discarded entirely. These 4 steps, Decompose, Delegate, Describe, Discern, are not a linear checklist. They form a continuous engine, an iterative loop of human-AI collaboration. The Discern phase ensures that despite the automation, the educator remains the final, vital arbiter of academic truth. When we apply this framework down to the student assignment layer, the implications change. Traditional assignments have a core vulnerability. They rely almost entirely on output-based evaluation. We grade the final essay, the completed code, or the solved problem set. Because an AI can instantly generate A-grade essays or problem sets, assessing only the final output is pedagogically void. It tells you nothing about what the student actually learned. This necessitates what we call the assessment inversion. This chart shows the new metrics for evaluation. We are no longer grading just the output. We are measuring process verification on one axis and the student's reasoning on the other. To do this, you design assignments where students are required to use AI. Their task is to critique, refine, and iterate on the AI's output, proving their understanding through the correction process rather than original generation. AI does not break academic integrity. It forces a necessary evolution away from rote memorization and toward deeper, reasoning-based evaluation. Zooming back out to the macro level, integrating this operational system into your syllabus offers a massive strategic advantage. This chart shows the traditional burden of course creation. Educators lose countless hours outlining lectures and drafting rubrics, leaving a tiny fraction of time for engagement. Executing the 4D loop delegates structural heavy lifting to AI, rapidly reducing setup time and flipping the ratio entirely. This reclaims a massive time dividend. You can redirect those hours toward high-value pedagogical tasks, designing adaptive learning paths, providing differentiated instruction, and focusing on one-on-one student mentoring. By intelligently offloading administrative structure to a machine, educators gain the time necessary to be more deeply and effectively human in their teaching. The future of education is rapidly restructuring around these networks. AI fluency is no longer an optional digital skill for early adopters. It is a required baseline literacy for all modern educators. Remaining a static content deliverer in a dynamic ecosystem is a professional risk. The systems will simply bypass you. But those who master the 4D protocol position themselves to lead. You become the bridge between raw, emerging technology and rigorous, proven pedagogy. Mastering this execution protocol is how you move past surviving the technological shift and begin architecting future-ready learning systems.